Okay, hi everyone. This is a language design review meeting, incremental language design, and we are looking at a variety of new potential features for Wolfram language. All right, I'm told I need to run the prototype build for the first thing here. So did you implement Splice with a head?
Yep.
Does it seem to be sensible?
Yes. I mean, we need to find uses.
That's not a good sign. Why is this spinning? Well, I mean, this is the Xkernel, so who knows? Okay, so what you're saying is that I can say f of a, b, splice, what is it, splice list CD or fcd?
It's list. I was thinking about F, but I thought that we could give an opportunity to F to evaluate, and we don't want that.
I see. Good point. Yes, that's a good point.
And if this is supposed to be kind of a sequence, you know, a nicer version of sequence, then it should be a list.
Fine. Yeah, I think a list is a more flexible thing.
Mm-hmm.
So let's see. So I think this is just going to be a useful thing. I don't really know what. I assume that we don't want the function to be first. Anybody got an opinion about that?
I prefer it second because
Yeah.
it keeps the same position for a list.
What do you mean?
One arc form.
Yeah, okay, fine. This seems fine. I mean, are there any other holding issues? I mean, so the one question would be, one could imagine a third argument to Splice, which is a processing function. So let's say it was hold of, I don't know. I'm not sure whether this makes any sense. I'm just asking this. Let's say it's f says what you splice into, and then the third thing will be an action function to apply at the time of splicing.
Do you mean hold of a splice rather than splice of hold?
I didn't mean hold of a splice. I meant that you're holding this thing, and then this action here would be, for example, release hold, and that what would happen is that upon insertion, this would apply the function, this action function, to the payload before the splice.
To the payload or to the whole? I mean, to the payload, it's not that useful, right? Because you can just apply it to the payload.
How?
Right there.
No, but how do you? Wait, oh, you mean?
I mean, doesn't make a difference? Yeah.
I see. So what you're saying that what I could do is f a b release hold, but doesn't the release hold?
No. I more mean just that you know, you might as well. What's the point of holding C and D if you're just going to release hold it before you put it into the F? Presumably, what you want to do is you want to put it into the F, you know, in held form, and you want F. You know, if F is a hold all function, you want F of A, B, C, D, right? Where C and D don't. I mean, that's your end, you know. But if you apply release hold to C and D before it gets inserted into the F, then they're just going to be evaluated.
Yeah. Okay. Fair enough. Well, does this seem at all useful? So, go ahead.
Well, I was going to ask a quick implementation question, which is, I mean, so is this implemented with like up values basically?
Yes.
Or
yes, like nothing.
Okay, yeah, but I guess
yeah.
So I guess then the only question would be if there are any, like, if there are any places where sequence hold is used where this might mess with it. I mean, I guess this is a lot safer than sequence, so maybe there's no need for a sequence hold like concept, but yeah.
Well, it'd be worth looking at places where sequence hold is used, because this would be a good replacement. I mean, let's see in the documentation.
So you mean that if we put set, for example, in the second argument, something like that?
Is set sequence hold?
Yeah.
Well,
Yes, it
okay,
is, because you can say X equals a sequence, which is horrifying.
yes, right.
And this is a much better alternative.
Yeah, I don't see a big, I mean, yeah, right. I think this thing is inert enough that if you put set in the second argument, you kind of know what you're doing.
Okay, here's a question. What is this thing a pattern or is this thing a literal? Presumably it should allow a pattern. It should allow F or G and so on.
I see. Right now it's a literal, but we can make it a pattern.
Seems nice if it's a pattern, if it can be done efficiently. I mean, clearly the literal case should be the most efficient. But I mean, I could imagine this being, I mean, in things I'm doing, at least there's a lot more composite headdress type activity than we've ever had before. And I can well imagine matching on some kind of elaborate head.
Right. But if the elaborate head is an alternatives expression, it gets messed up, right?
What do you mean?
Good point.
If the head of the thing you're splicing into is alternatives FG.
Well, no,
Well,
it's
then don't use verbatim or something.
Yeah, you'd have to use verbatim, right?
yeah, it's a
exactly.
pattern
Sure.
map. I mean, it's a pattern. So whatever it,
Right.
it's going to do the pattern matching thing.
And I think that's fair. I mean, it's like if you're applying this to an expression that has weird pattern, sort of pattern symbols in it, then sure, you might get some slightly weird behavior.
Right. Right. We solved that problem with verbatim all over the place. We just document it and people understand it. It's fine.
I just want to admire this. Isn't this lovely?
Yep.
It's going to be really useful. This unbelievable amounts of code I've written that has ridiculous, maps and things that is now unnecessary.
Do you know if the if it's now like vectorized in any way, or is it still similar efficiency to map?
I don't know.
I don't know. You go ahead.
I was going to say that I know Rob was trying to make it more efficient for the packed cases and things like that, but I don't know the status of that.
But this
Yeah,
is
I
a
mean,
real
that-
actually. He certainly
I mean,
knows.
already it's very nice, but I think if it's vectorized too, then it will be super mega nice.
Well, but ask Rob. I mean,
Yeah.
he's certainly aware of those issues.
Yes.
All right. Should we move on?
There are
Yeah.
some examples just in case. The only thing I was thinking about is when the head is a hold head.
So
Okay,
wait a minute. You're talking about Splice.
Yes.
Okay.
Yes,
Where do I go for the examples? You want me to-
Open this section.
In the
oh
agenda.
gosh.
And the
Why was I not paying attention to that? Okay.
Oh, yeah, in particular, if it's hold complete, right? Because that will stop. Or actually, I guess hold will stop the F values too, right? So
Yes. So that's important, for example, for association. So right now, nothing is not doing anything in association. So this is going to be the same.
Sorry. Held expressions.
Yes, there. So
That's fine. That's very nice what that's doing, seems to me.
So it has to be at that level. So of course, if hold was hold of a list, then yeah.
wait, sorry, how does that work? I mean, if it was hold complete, would it not work? Or like, I mean, how is the up value working when it's inside of a hold?
You can use up values in a holding function, just not hold all complete.
Okay. So let's see it. So with hold complete though, it'll, I mean, I think that's okay. I mean, that's such as the
No,
life of
Well,
being
I
a
don't
hold
understand. Why
complete.
didn't that work?
That's the case. That's too deep. So
Oh,
the list is never evaluated. And so we never see there is a splice there.
I see. But if that was actually a hold itself,
Exactly.
then it would work. Because that's not a particularly useful case. But
We
it would
need to
only
get rid
work
of
if
the list.
Right. If you remove the list and you have hold, then it does work.
I have hold in the splice.
Exactly.
But now one last case to try is to do that again, but with hold complete. And I guess here it's not going to
It's not
splice
going to
in.
work.
Right.
That's life.
I think that's desired though.
Yeah,
Fair
Right.
enough.
I agree.
Yeah. Hold complete. That's what you wanted to do.
All right, mixed cases. Do I need to read these? What are these? Are these?
No, this is just showing that depending on the head, you have one or the other splices.
Oh, I see. Nice. All right. Any more to say about this? Oh, what was the thing you said about nothing not working in associations? So if you say A goes to B, X goes to nothing, I mean,
It'll
you don't
stay.
expect that to do anything. Yeah.
I believe it does do something though. If you do A goes to B, comma, nothing, then I think the nothing does go away. I thought.
Really? I thought it would just be an error in the association. Wow. How would I put it in there though? How would I get it in there? Other
Right.
than
I mean, it's usually pretty. I found that nothing in associations, like I haven't really used it much because again, yeah, I mean, normally, you can't like map over the association and then replace things with nothing and have the keys disappear, right? So it's pretty
I-
contrived when you can actually use it.
I didn't
Why,
know
why
this.
would it not behave this way?
well, because I'm just
Central
surprised that
dogma.
anything sort of naked at the top level of an association doesn't just cause a spew of error messages.
It may be a fluke because something goes through an intermediate state of a list.
It's just that, I mean, the so-called central dogma would have nothing disappearing just like it does in list, wouldn't it?
Only if it was in a, well,
That's different. I meant the case where it's naked there.
why does the central dogma have anything to say about the naked case?
Well, just because the central dogma, I believe, says it's supposed to behave like it was in a list.
Or like the values were in the list, but there's no values. It's just a
Right.
nothing.
Exactly. The
But
central
that
dogma
is why I think that in the first case, the central dogma is violated a little bit because the nothing stays.
Mhm.
Yes, I mean, there will be an argument for this disappearing in this case.
I'm not sure that the central dogma really, well, I don't know if it's ever been stated formally, but I'm not sure it really means that only the values behave like they're in a list.
All right,
I
but
see
look,
your point that this isn't a value.
yeah, right. I think
Right.
let's not cross.
Okay.
I don't think there's anything much to do here. I do wonder about an analog of splice in associations, but I think it's not relevant.
Well, I do think also that, I mean, it might be too late now, but it might have been nice if that, I mean, I know it's I think it's too deep for up values, right? But I mean, that case there with the nothing in the value, it might have been nice if that.
I think it's not too late. I think we could investigate that.
But also, isn't it you can only have up values like one level deep, right? So
At present, yes.
Yeah.
I mean, that's been true for 35 years, but that might not stay true forever. I mean, that awaits a rewrite of the evaluator, which I think
Actually, does values, if you look at the documentation for values, does it have like a second argument or something that you can wrap the values in? Because otherwise, if you say values of that association, you're going to get the bizarre property that the keys will have a different length from the values.
that is really weird.
But look, if values has some obscure second argument that's like, oh, you can wrap the values in this head before returning them, like hold.
It does. Wrapping each of them with a head.
Right. So if you try hold, let's see if that works. I mean, I guess it doesn't even have to be hold; it could just be F. But yeah, okay. Still, that's a little terrifying. That you could write some code that gets the keys and gets the values, and then tries to map thread them, and it freaks out.
Indeed, that should definitely be in possible issues. I think this goes in possible issues. Okay. So, all right, let's move on. Groupings and unary functions.
Yes, so this was discussed in TILD, and the thing here is that the unary case is kind of singular for groupings, and we may not have right now the best heuristics of what.
Okay, well, so let me understand what the issue is. So the issue is that if we say groupings of x, y, comma, f arrow 1.
Well, that's too degenerate. Try g comma 2 f comma 1.
G2 F1.
Yep.
Why was that first thing too degenerate? Why was that? I don't understand why that was too degenerate.
Well, let's discuss the heuristics this is using, and then you will understand that case, I think.
Okay. All right. Okay.
So the question is that we could put strings of f's, and this wouldn't change, of nested f's, and this wouldn't change the.
By the way, if we don't have an example with groupings with framed in as the function, we should add one.
Okay, I love that.
Okay.
So in the unary case, the issue is that you can have f of f of f of f of f as deep as you want, right?
Exactly. And because this is generating trees with the number of, with fixed number of leaves, 2 in this case, then we could have as many as we want. And so
okay, the point is that this is, I see. So the main issue is groupings is being sort of parameterized by its leaves, by its number of leaves. Now, an interesting issue is what leaf count does on all of those things. Oh, how curious. What does that mean? Why is the leaf count bigger for those subsequent ones? I would have expected.
Can you do it with F instead of framed? Because otherwise it's very hard to tell what's going on.
We used frames for both.
What? Oh, you mean frame? What are you doing? What
Framed goes to 2, framed goes to 1. And you can visually see the nesting.
Can you?
I would assume.
Well, I wouldn't assume that because I would have thought what's
I mean, you can just look at how deep.
Oh, framed. It might have to do something for that.
What?
Like frame.
Oh, because 2 argument framed. Yeah, just do
row and a list. I don't know.
Yeah, framed compose row or something.
And list.
Does that really help?
I don't know.
It helps with the depth actually, but
Yeah.
but the
Not with the unary operators.
the leaf count really
Oh,
should be 2 for everything though. Why is it 4 and 5? I don't understand how leaf
count is counting the heads.
Oh, the heads. I see.
But so why is that
Well,
number?
You can apply the unary operator different numbers of times in different groupings.
Well, that's the issue, though. That's what we're talking about. What I would have expected is uniform leaf count across all the instances.
Well, no, but the heads, it's counting the heads because you can apply, you know, for example, if I had g of xy that has, you know, the leaf count is getting 1 from a head. But if I had g of f of x comma y, then now I have 2 heads that are getting counted, right?
I think the clearest way to understand this is to use f and g and do tree form or expression tree.
Right. I mean, it seems like the real issue though is just that, you know, right now it's got g of f, you know, g of f of x comma y, and then it's got g of f of x, and it could keep going, but it has sort of arbitrarily decided to stop at 2, right?
But
right.
I don't understand. I would have expected that these things, the issue is we've got 2 genuine leaves, right?
Yes.
But the leaf count of the expression is the other parameter. And given the genuine leaves and the leaf count, you determine what set of trees you can get.
Well, the thing is that in the first 3, we are inserting 1 f. In the others, we are inserting 2 f's. And I think that's why leaf count.
This has nothing to do with the leaf count, right? I mean, the whole point is you can add f's without affecting the leaf count. Look at
no. You do affect these leaf counts. You affect.
Oh, but that's not what grouping.
So Stephen, that's not the default expression tree. If you do expression tree, comma atoms, then you'll see the leaf counts that are showing up there.
Okay.
And by the way, this is on a future, like this is a topic for a future LCC meeting of if leaf count should take the heads option. And if it did, then you could say heads goes to false and you would get 2 for all of those.
Exactly. Exactly.
useful,
I
yeah.
think that would be very useful. I think that's a good idea. And we could just decide that it's a good idea now, because I don't think leaf count takes any options at all. Okay.
But either way, I don't really see what leaf count, how this solves the problem of how many times you can nest F.
Because our non-genuine leaf count, okay, is either 4 or 5, and if groupings could have an argument which says
No, but it could be
what value-
10. It could be any number. It's just
I
it's
know.
arbitrarily been bounded at 5. Yeah.
I know, but I'm saying, let's say that groupings could take an up to n for the hour leaf count.
Well,
parameter.
then I feel like if the idea is to have an option like that, then really what it should be is it should be the maximum depth of Fs. Or it should be the maximum depth, maybe just the maximum depth of the expressions, because you could also have 2 unary operators and you could have any sort of combination of them.
Why do you think that's a better idea than bounding the overall number of elements in the expression? Bounding the depth.
I just think it's a little less arbitrary.
One argument is that leaf count is counting things like rationals and complexes as having multiple leaves within them, despite being atomic. Like, I just don't think leaf count should be tied to this.
It's kind of
I mean,
crazy.
the actual leaf count function is
Right.
weird. I mean, like, I think it's yeah. I mean, that it is a low level thing that does not reflect how you should think about expressions, I think.
But it also its documentation should be updated, and it should say, for example, that it counts heads, and it should have a heads option. Without question, it should have a heads option.
Right. But so, I mean, with the trees here, though, the issue is that if you had, for example, a leaf count bound, or even a depth bound, actually, if it's just like a depth bound over the whole expression, then the issue is that it'll be very unclear. If you set it too low, you're going to be missing a bunch of stuff, and it'll be kind of weird. And if you set it too high, then half of the results are just going to be F of F of F of F of F, when realistically, you probably just want a policy like the current one, where it's like, oh, just apply F up to depth 2.
What is
or
the
just
current
apply F
heuristic?
up to depth 1?
The current policy is that there will be a maximum number of Fs equal to the number of leaves. It's a bit arbitrary, but it was easy to implement. It's just a way of bounding the number of possibilities.
Oh, equal to the number of specified leaves.
Exactly. Yeah.
That's totally arbitrary, because it has nothing to do with the number of leaves.
Right. So I agree, it's totally arbitrary, but it's difficult to choose which one is the right one.
I mean, you kind of maybe would like to, well, let me see. You maybe like to have like okay, so for every unary operator you have, you'd like to have a number that's basically how many of this unary operator can you have sort of directly above you before there's a non-unary operator.
What is this
if that makes
M
sense.
thing? Allows at most M sub I occurrences in any given grouping of F sub I applied to K sub I elements. What does that mean? Is that not what we want here?
Well, but that's not on the stack above it. That's just in the whole expression.
Oh, is it?
I assume so.
Let's just say 1 here. Okay, so that
Can
allows
you do the other kind of expression tree, because this is much harder to read, I think. Thank you.
Okay, so that appears to have only 1 F altogether. So let's say we have 3 Fs altogether. Oh, that's rather nice. So the only issue is possibly enhancing the M argument. The question is, what is the default value of M for a unary operator?
Well, it's not quite default value of M though, right? Because in the default behavior, there is no default value of M right now. I think it's just that.
No, the default value is infinity for M.
Exactly. Yeah. It's
Well,
there is a global maximum, and the M's are
Except that M is artificially not infinity for unary operators, because otherwise the whole thing would blow up.
right, but what I'm saying is that it doesn't have a single value for unary operators. I mean, unary operators are not
Yes.
bounded. That's not the mechanism by which they're bounded, right? They're bounded by. I would kind of argue that the way that you'd like to bound unary operators is basically by saying, you can have two F's kind of in a row before there has to be some non-unary operator, right? So like you could have F of G where G is not unary, of F, right? That's okay. If you have 2 as the maximum depth of F's you can have, right?
Oh, right, and that's relevant if F is idempotent, for example, or if F is self-inverse. Then you might very well want to, there might very well be cases where F of F of F of F is irrelevant.
Well, yeah, but also there are cases where, so for example, if you have 2 unary operators, then you can also have, F of H of H of F of F of H of H of F, etc. And then I think, again, what I think would probably be a reasonable thing is just to say, in that whole chain of unary operators, until you get to a non-unary operator, there can only be X, some maximum number of F's, right?
I see. That's an unclear case. I mean, if you're mixing 2 unary operators,
right? But
okay.
it can't just go to infinity in that case.
No.
So.
Oh, I didn't know there was that orderless option. That's really nice. Drat, I should have used that for a bunch of things. Is that really consistent?
We were trying to imitate what our expressions would do if they had an orderless attribute.
No, I understand, but is putting it, F arrow K comma orderless, right?
Mm-hmm.
Okay, what are we going to do here? Okay, do we have proposals on the table for what to do?
So Brad had proposed a possibility which I interpret as you have all groupings compatible with not having 2 unary operators together.
So who proposed this? Brad Klee.
Yes.
Yep,
Brad.
Brad
Okay.
Also.
What's that?
We have Brad here also.
Okay.
Hi.
Yeah. So there is this example of these complements there, showing the 2. So if you run that code and the following lines.
Which one? These up to compositions?
Yes, that, and then the example where it compares the 2 results. So that's showing what groupings does that Brad's function does not, and vice versa.
Oh boy. Sorry, which one shows?
So R1 is groupings. And so you see how we have 2 boxes together various times. So what he is doing is forbidding those cases. I think that's the key point.
Yes, which makes some sense. I mean, one might also
box could be not, for example, and we may not want to track 2 boxes if that unary operator is self-inverse.
Yeah, I know. But the Christopher case of multiple unary operators is also questionable. Like, what would your thing do with multiple unary operators?
Mine?
Yeah, can we try that? You've got...
It already does have multiple unary operators. It uses identity too.
To do what?
Wait, it has a square. What's the other unary operator here? Maybe do something other than identity, because identity is a bit hard to, yeah, there we go.
Okay.
So wait, there are some F of X's. Oh no, sorry, that F is around the outer. Yeah, never mind. So how does it, what's its policy on, f of square of x or f of square of f of x? Does it just never apply unary operators on top of each other?
Well, the way that it works now is, yeah, that's basically it. It never implies them on top of each other. It tries to apply them one time only at maximally through the expression tree.
Okay, so one possible parameterization would be a maximum. See, it's not good enough to say. Yeah, one possibility is you're sandwiching unary operators between non-unary operators. This is your maximum sandwich amount. Between two, so there's also the case where there are no non-unary operators, where you have like 3 unary operators and nothing else. Am I making sense?
Well,
And
what does it even do if you do that and then you give it a list of more than 1 leaves? Does it just fail? Because you can't make a tree like that. If you give it 1 leaf, sorry, if you give it 3 leaves and then only unary operators, it cannot construct a tree with 3 leaves only using unary operators.
But it could do an outer product over the unary operators and the tree leaves of some sort.
Okay, that's
right,
never going to work, right?
Well, yeah, actually, that's probably a reasonable thing for it to do. Yeah.
Which
okay,
thing?
fine.
Which thing is a reasonable thing?
They're returning an empty list.
Yes, that's perfectly
I think
reasonable.
that's the right thing.
So
to
is
do.
this.
Yeah.
I mean, and I think in this case here.
What if you have f and g? Yeah, exactly. Or sorry, what if get rid of the second x? Just have f and g and 1 x.
That is funkalorial.
I mean, I think that's honestly the most useful output it could give.
Yes, but it's a little bit unexpected. I mean, so why does that limit?
Well, in this case, it's just limited by it only used f and g once each, right?
Exactly.
Which is kind of, which I guess is because it's the leaf count. It's because it's the number of leaves you gave it.
Mm-hmm.
But if you gave it, yeah, right.
So its current heuristic is it uses the global count in the expression of the number of unary operators is equal to the number of leaves.
Right.
With a global count of how many times f appears is equal to the number of leaves.
Mm-hmm.
Right.
Which I suppose is so that f can in principle go on every leaf, or it can move around the expression or something.
Right, but so that's one possible parameterization, to just specify a maximum number of occurrences of each given operator. So for example, we could imagine in that, look, I don't understand. Isn't this exactly the right thing, this m sub I here? Isn't that equivalent to what you're presenting here? And the only question is what the default is. Right?
Yes.
Well,
so that's acting per operator. And the question is, what's the global heuristics?
Hold on.
I mean, also, I would argue, though, that it might be nice to, instead of doing it but like that, to do it based on, the depth of the operator instead of a chain, because otherwise, this number is could be a bit too low. Because if you make some take here's a simple example. I mean, this is like a super, this is probably a kind of useful application of groupings, is something like I have and, or, and not, and I would construct all the different basically Boolean circuits.
Yes, that's
tree
probably
Boolean
exactly
circuits.
what Brad was doing, working on something for me.
Right, and so then the point is that I want not to be able to go on any. Not only do I want to be able to have not on all the leaves, but I want to be able to have not on every leaf, and I want to be able to have it on every one of the higher expressions too. But if m is equal to the number of leaves, then there won't be enough knots to go around, right?
Yep.
So that's why I think that it would be better if you just sort of said something like, oh, you can never have more than 1 knot in a chain of unary operators, or you can never have more than 2 knots in a chain of unary operators, or something like that. Because at least then, you could there are enough knots to go around, but you're never going to have 25 knots all applied in a row.
Okay, so what you're saying is there's unary icing that you could put on everything. Is basically what you're saying. That unary is kind of free so long as there's only one of it. You can
I don't know if it's one. I mean, it could be more than one, but yeah.
Right, but the default will be how many?
Maybe one.
Right. I mean, so what you're saying is that if you have a unary operator in the mix, you get to add it as a piece of icing on anything that you've got there.
I would say so. I mean, at least, as the default case, at least.
Right, but so that means you can decorate. You can put a unary. That's not a silly idea. I mean, that seems quite sensible and quite explainable. That you can add the unary operator to any. You can add it just one sort of dot of unary operator to any subpart of the expression.
But again, the one caveat is if you have two unary operators, you can add it in one place. You have to make clear that it can only appear sort of once in any chain of unary operators. Yes. Otherwise, you can just do FG, FG, FG.
I understand. So what has to happen is that if there are multiple unary operators, the icing is you're basically doing, F, G, F of G, G of F. Those are
any place that icing appears, it can only contain, some number of Fs, some number of Gs, etc. Right. And by default, maybe that number is one.
I think the only reasonable default is one.
Yeah. Okay. Well, I mean, the question is if it could be settable, but maybe
no, it should be settable.
It might make the syntax. I mean, groupings. The syntax is already pretty complicated. It might make it even a bit more convoluted to have a thing for that. But yeah.
Well, most M occurrences in a given grouping, that's the global M. And then this would be infinity, I mean, probably the right form would be, I mean, do we care about this for binary operators at all? This number of operator insertion, or is it irrelevant? I mean, I was thinking it would be of the form.
Well, I'm not sure what it would really mean. I mean, for a binary operator, what would it mean? It would mean how many times can you use G, in a chain of binary operators before you reach a ternary operator? Or would it just be crazy. How many? I mean, the more useful one, if you were going to have something like this, but this is different from the unary case, would be something like how many Gs can you have on the stack for any given G is? Like how many Gs, how deep can you be in Gs? But I think that's a different case, and yeah.
All right. So wait a minute, Brad, is your function equivalent to basically this kind of thing?
I tried to find output equivalent form, but I was unable to. My first guess would be that you can go to groupings and. No. This is not a capability that groupings has right now. This is this thing that we've just been describing about icing, about thinking about limiting. About saying you can add a unary operator as icing anywhere, and when there are multiple unary operators, you do this kind of multi-icing type thing. I'm just asking, is that equivalent to what your up to binary compositions thing does? Yeah, it sounded reasonable to me, and I understood Christopher's caveat, but I don't necessarily understand the analogy to icing. Because here's the thing. You never bake a cake, I guess, and then just put on an infinite amount of icing. That would be crazy.
Well, right. I mean, this is a strategy of to not to avoid the infinite icing case. But yes.
What else can we describe it? It's
Well, I just think of the unary operator thing in terms of it has no constraints.
Well,
everything else.
But we need to give it constraints.
Yeah. Otherwise, right.
But everything else basically has a counting constraint. But
yes, right. But this is the whole point. The question is, right now the question is, do we give it a global constraint or do we give it a local constraint? And what I think is being argued is that it's better to give it a local constraint of how many times can it occur in there is a slot in which a unary operator can occur. There is a sub expression that can be wrapped with a unary operator. How many layers of wrapping paper, to use another analogy, can we use? Right?
Yeah, I think that makes sense. And I also think Christopher's caveat was important. So we should make note of that.
So if I understand correctly, the MI is limiting the number of Fs in a grouping. The new number would limit the number of nested.
Right, but I think but I think at least my understanding is it's not just nested, but it's like nested in a chain of unary operators. And I'm not sure if there's a good analogy, if there's a good behavior for non-unary operators.
Yeah, that's what I mean.
Yeah,
right,
okay.
But
there would be a separate thing that might also be useful, but is a totally different thing, which is which could work for non-unary operators, is just basically restricting how deep you can have. If there are already 3 Gs on the stack, you can't add another one, right?
Yes, stack depth.
Yeah, that's a different thing, though.
I noticed Nick is here. Actually, there are 2 Nicks. The Nick without a C. Do you have any comments on this? Actually, either Nick, but go ahead.
Well, I have the idea that the global counter is kind of better at least for combinatorics. But yeah, having both is definitely beneficial. That's the only comment I can give.
Well, you're arguing that we should not get rid of the global counter.
No.
Yeah, well, I agree.
Well, I don't think we can. I think that one for sure.
Right, but so the issue is that the default becomes, instead of, okay, so let me suggest this is the default then, and there could be some bizarre version of the current behavior by doing this, for example. Although I consider the current behavior less than optimal.
By the way, is there a
I don't
reason
have
why
any problem in removing the current behavior.
Say it again?
We can get rid of the current behavior. It's not that
Somebody
useful.
should check a bunch of my posts, because I'm pretty sure these are used in click to copy code, because I don't think I was really aware of this issue. And I think I've used it to generate Boolean expressions, for example, and arguably done the wrong thing that way, but that's a different issue.
But I was going to ask, should the infinity comma automatic be in a list?
As opposed to not in a list.
Yeah, I don't know.
Well,
I was thinking the same thing, that we could have a third element there.
Having a list does make it it's already very nested by the time you get here.
Yeah, all right,
so having another level of list might be
fair point. Okay. Now, okay, can we just talk for a minute about stack depth, about things on the stack?
That's the 4th argument.
Well, the thing we don't have, which I think we might consider, is random groupings, possibly. Back in times of SMP, I had this function called rex, the random expression generator, which rears its head every so often, which was essentially a Markov chain random expression generator, otherwise known as random groupings. Would random
Actually, I would guess that the better way of doing that, we have a similar thing with like subsets, right? Where there's no actually, maybe isn't there a random subset? I think there's a function repository random subset or something. But if you want to do it, in the top level, what you do is you can compute the number of subsets, without too much difficulty, and then you just do subsets, and then you use its second argument where you can select which subset do you want. So yeah. It kind of seems like the thing would be if it were easy to get the number of possible groupings, because unlike subsets, I think that's not as trivial a calculation.
No.
And 2, if you could get if you could ask for a particular index.
I think because it's so difficult to ask for the particular index,
Well, to
Well,
get the
let's
number of
see.
groupings. I mean, yeah,
Yeah, I
it's
mean-
true. I mean, getting the number of groupings is painful enough that
Look, we've had
Like-
this issue in a number of cases. We have it for cellular automata also. How many cellular automata are there that are totalistic with n neighbors, blah, blah, blah. And, you know, we have considered having a function that will answer questions like that.
like a single function that answers all those questions.
I don't know if that makes any sense. I don't know if that makes any sense. No, I mean, it seems crazy. I mean, look, we've got a separate function for the number of groups of a given size and things like this.
So
The-
for simple cases of functions, of single functions of given unary, we can do it via random tree. So first creating the skeleton and then placing the leaves. But for the general case of multiple functions of given unaries, getting a tree with the right distribution of probability is probably quite difficult.
But why is this? How can you specify in random tree how many binary?
No, we just can't say the number of nodes.
Right. So you can't say. I mean, you might be able to say, give me a random binary tree.
Yes. So there, I think if we have a single arity, then it might be doable. But
Well,
not for
the other
general.
possibility is that we could have a groupings. Look,
Like a tree distribution.
yeah, something like that. What I'm imagining is, I mean, I could imagine here random tree of n arrow k giving you a k-ary tree with n nodes and k, where instead of this k, a random tree of n arrow k, you know, something like that, being a random tree with this seems useful actually.
Yeah, that could be nice.
Yes, we had already planned to generalize the first argument to varieties of trees. It's always difficult to find the generation method that guarantees uniformity.
Mm-hmm. Well, I mean, what I was thinking is, what I was about to say is, why not give a grouping specification in the random tree? See, but the thing is, random tree has a different, that number there is something not accessible to groupings. That number is the total, you know, tree element count for the groupings.
Mm-hmm.
It's size versus leaf count.
Yeah.
Oh yeah, because right, this is not right. This is a different number, and also I think, you know, random tree returns a tree, not an expression. So it's, you know, if you want a mechanism for returning random groupings, I don't think that's really the best way to do it.
Right, but the thing we don't have in groupings is something, yeah, usually it is deterministic. Without the unary stuff, it's completely deterministic how big the trees are going to be given just the number of leaves.
Mm-hmm.
Correct?
Yeah.
Yes.
That's even true if you have different arities of operators.
Well, it'll change if you have different arities of operators, but you know,
No, but I
it's
mean,
still,
if I say groupings,
if you have 10 leaves and you have a single tenary operator, then there's only one grouping you can do. Right.
Right.
But if you have a binary operator, then again, you're bounded by the whatever it is, the log base 2 of 10 or something like that, floor of log base 2 of 10 for the depth.
So the modulo order, this answer is uniquely defined. It's only the unary case.
And each one, okay, I'm confused by this.
Just do whatever it's called, length of tree leaves of tree expression tree of those.
Well, alternatively, I could just do level, I just do how many symbols are in here. Right? If I just say level of hash -1, heads goes to true.
Why do you want heads?
Well, they all have
You want the
4.
heads if you're trying to count the size.
Yeah.
You don't want them if you're trying to count.
Oh, you're trying to count the size. Okay, yeah.
Okay, so what's happened here? I am so freaking confused here. Okay, so there are 3 Fs.
I think it's because you have different arities. There are like different partitions.
Yes, right. Right. By the way, we should talk about this in the groupings possible issues section things, that the leaf count is not constant.
Well, the leaf count as measured by the leaf count function, but that is not, if you ask me what
No.
the leaf count, the true leaf count of these expressions is, then it is constant.
Yeah. That is a bit unfortunate. The leaf count is not counting what we would now consider to be leaves.
I mean, it just does a low level
Well,
thing.
it also,
At
if
least
the first argument is a list of things other than atoms, then you're just doomed because leaf count's going to be counting the leaf counts of those, but
Yeah,
they're
sure.
leaf from the point of view of groupings.
Right.
Yeah.
Okay. But I'm still arguing that there might be a case where having the actual number of atoms bounded would be useful, but I'm not sure. But okay, but back to random trees. Do we imagine that there are many tree distributions that we will include in random tree? Are we expecting that we will have a whole zoo of tree distributions as we do for things like graph distributions?
Yeah, probably. There are cases like, do you count reordering of the labels?
Yes. I can see that. But so do we actually have a project? Have you talked to the statistics team about this, Ian?
No.
Maybe we should, because I think it would be good to. They seem to like doing these giant literature surveys of all distributions of a given kind. Right, because I mean, what we're saying is, what we'll need is things like this, right?
Yes, a parameterization of possibilities. Yeah.
Right. But whether we want to introduce into random trees something, I mean, do you know the algorithm for doing unary trees?
Do you mean for just uniform distribution of unary
Yes.
trees?
Yes.
I think it should be straightforward. Like the algorithm I'm using basically views our general trees as binary trees, like the first and then the rest.
Didn't Don Knuth send us?
There's like an isomorphism between binary trees and plain trees.
Okay. Didn't Don Knuth send us a piece of code that we put in the function repository for doing this?
That was for what are called free trees. Like
What are those?
they don't have a root.
Ah. Okay.
Yet another tree distribution we could have.
Sounds to me like we're going to need a bunch of tree distributions. So we should make sure that's a project, and please talk to the people who did the graph distributions. I think makes sense, Ian.
Yep.
Okay. So possibility of doing this, but we're not sure. Maybe you should look into tree distributions first. With respect to this, I think what we're concluding is that we are going to use the wrapping paper layers, like aka the icings method. We should have it as 3 arguments here, wherever we had that. The FROK, comma, because we're decorating the K with things like orderless, right? This case here.
Yep.
Okay. So this will be infinity, comma 1 will be the default, which is a change. Which is a little bit scary that we're making that change. A little bit scary. And we could have infinity, comma automatic be the default. Let's see what we break. Good test cases, do we break a bunch of stuff I've done, for example? Do we break test cases and so on by making that change? Fallback is we make the default be infinity, comma automatic as it is right now, and we have infinity, comma 1 be just a documented thing you can do instead.
Yep.
And for the case where K here is not equal to 1, the last argument will do what? Will it be an error, or will it do nothing, or will it do something? I would propose that for now we make it an error.
I don't know. I would have to implement this first and see. I cannot predict the
Okay.
problems. Mhm.
Okay. But my initial take would be if k is not equal to 1, the fourth argument should not be allowed. The fourth element should not be allowed.
Okay.
Comments from anybody else? Anybody? Nope. Okay. Good. All right. That was that. Shuffles.
Yeah, so there were a handful of popular shuffling algorithms in the function repository that are deterministic. And the general question was, does it make sense to have a shuffling function that potentially has methods? You know, a random
I have no
shuffle would
opinion.
be a
I've
random
not used. I've never used shuffles.
Mhm.
Anybody got an opinion about this?
Danny or Rick, that would
Well,
probably be.
yeah, they could be used in, I suppose, experimental designs where you do want some kind of ordering, perhaps. Other than that,
I mean, random sample will give you a random ordering of a given.
right. I'm thinking there might be situations, particularly in the context of experimental design, where you don't want it to be random, but you want to be able to change it in a specific way, and that these shuffles might provide that.
Is
More
there a
generally,
parameterization of shuffles? I mean, I don't know what the difference between an in shuffle and an out shuffle is.
I don't remember, but these are standard terms. We checked that.
Right, but the question would be, if there is a number, this is an EdPeg kind of question. This is, I mean, because given a list in which some elements are identical, there is a numbering, is there not? Maybe Brad knows this. I don't know. There is a numbering, unique numbering for possible orderings, is there not? In other words, given permutations, right? You can specify, it's trivial to specify, a number between, 1 and n factorial that specifies a permutation if none of the elements are identical. If some
Right,
elements are identical, it gets more
yeah.
difficult.
I'm thinking that perhaps we could consider this like a named permutation and put it in permute, the second argument of permute.
I think that's an interesting idea.
Yeah.
Because permute takes a permutation or a group collection. And so we could just say, this is a named permutation.
I think that's a good idea. That seems like a good idea to me.
Okay. Yeah. I mean, that way it's at least accessible and it's within an existing framework. So I think that when I looked at it, there are only roughly these 3 deterministic shuffling systems. So going with permute makes a lot of sense.
Fine.
Does it relate at all to find permutation as well?
Well, that would be the inverse function, taking 2 lists
Right.
and returning.
I'm just wondering if it can,
I think
yeah,
it's
right.
okay.
I mean,
yeah, it would be a bit strange to return a string instead of a
Yeah, I think
cycles.
so.
That'd be
Yeah,
a good
fine.
function repository thing.
but with cycles, just because I don't. Yeah, I mean, the cycles, you can always find the permutation group in the cycles. You can get that for any group, right? So you can always return cycles.
Yeah, cycles is
Right.
equivalent to a permutation.
Right. And
permutation
something that
list.
maps the cycles to the names would be good in the function repository, I think.
But how do you get from the cycles? How do you get the actual permutation?
This permutation list.
Oh, I see. So could I do that for?
Maybe you should be able to say, maybe can you say permutation list of, well,
No.
yeah, I mean, there's can you say permutation list of Mongian shuffle or something?
We could,
Oh, I
yeah.
see what you're saying.
Yeah,
Yeah.
for the second, because it takes a length. So the second line could be generalized to take a string.
Returns a permutation. I don't understand.
So cycles is a bit like the sparse representation of a permutation.
Right.
And so permutations are.
Oh, I see what you're saying. I see what you're saying. You're saying I could just have cycles 1, 2, but my whole permutation could be of length 10.
Exactly. Yep.
So I see. So it's like digit. It's like in from digits.
Yes. Or when you say I have a sparse array with element 2, but the vector has length 7. It's 2 lists in cycles. So it's a list of lists.
It's 2 levels of lists. Right, and I guess then the next logical question is, can you have Mongian shuffle inside of permutation group?
No, I think that would be a bit too much.
Yeah, okay, fine.
Okay, but so the concept would be, I'm sorry.
I guess if you really wanted that, you'd probably want to do permutation list of your Mongian shuffle until at the length, and then there's a function that gets you the cycles from the permutation list, right? So
Sander, our author here, is saying, look at applications and properties. Okay. I see, that's got a number of count of the number of shuffles to do. So that would be a nest of a permute.
It's a permutation power.
Yes. Oh, do we have a permutation power function?
Yep.
So you're saying that permutation power, boy, this is But this wouldn't work, because if you say in shuffle or something, it has no idea how long that shuffle is.
Right. We would have to go first through the conversion to permutation list, and then the.
Yeah, which I think is fine. I mean, the only thing is it becomes a little bit, I don't know, maybe this is like there's some line in the details and options of some documentation page that kind of makes it clear, like, because right now it's sort of implicit, like how do you define a permutation? Is it cycles, or is it a permutation list? And if we're making it so that.
Sorry, Sander's function is very nicely done here. Good work. This is very nice. Oh, this is interesting as well.
The idea of permute is just to avoid the introduction of a new symbol, but if it's usable, we can have the symbol itself.
Yeah, right. I mean, I think it seems nice, especially because I think it's also nice to have things like permutation list work. But I mean, it's just that I'm just thinking about like permute, nominally permute takes a permutation specification as its first argument. And there are several other functions that also take permutation specifications. And so we should at least maybe make it clear that, like, okay, well, maybe permutation and permutation list will take this thing, but this isn't really a full-fledged permutation specification that like permutation group will accept.
I mean, the thing that is a little bit complicated for me is that, Sander has done a very nice job here in these function repository functions. And the question is, at what point is it worth making system functions out of these things? And to what extent, I mean, because there are certain kinds of things which are definitely going to be too specialized for us to want to make system functions out of them. So it is unclear to me what the policy should be in this case.
You mean because if you just think that the function repository function is so beautiful and it's kind of specialized, just let it be.
That's what I'm wondering. I mean, I'm wondering whether that, it's whether it's easier to find it in the function repository than it is to find it as a sort of a sideshow of permute, for example.
There's no reason it can't be both.
No, there's absolutely no reason it can't be both. And it's certainly, we are just adding, people on the live stream are asking about this. We are just now adding, I don't know if any of them are live yet, links from function reference pages to function repository pages. It's a little bit, we're doing it a little bit gingerly because, the function repository things in general are not as robust, general, permanently designed, etc. But it's certainly useful to be able to do that. Although there are things which will appear in the function repository that we never expect to appear in the system because they're just quite specialized and quite a particular tower of corresponding to a particular workflow that's fairly specific. I am confused by this one. What to do with this one? Anybody got any thoughts about this? I mean, I think that the idea of inserting it in permute is interesting, and maybe we do that with the notion that many people will just use it from the function repository. I don't know. Anybody got further opinions? And I'm a little bit concerned about the creep of does it work in permutation power type thing.
Yeah, that's a good point. Perhaps we should just link from permute to these functions and the users would find them immediately.
I think that's the place to start. Let's do that.
Yeah, we'll do that provisionally. And if there's a strong case to revisit it, we can do that.
All right, just a couple minutes here on these. Let's take a look. Isn't replace at part of a potentially giant family that will be in this multi-replace business? Do we want replace at? Or is it?
Sorry, I don't really understand. How is this function different from just the level spec of replace? Is it just that you can tell it to replace or map at
You're giving it
of the operator form?
positions. You give it
a
positions and
at
then
a
it
level.
applies the rules at those positions.
But so it's the same thing as map at of the operator form of replace, right?
Yes.
Yeah, but that doesn't do what you want if it's like held code, for example.
Oh, or wait, let me think about
Yeah,
that.
I mean, it's very similar to what you just said. Map at with an operator form of replace.
Wait, what is the held? What is there a simple held code case just to understand it, or?
So
Like
if you were
they're
to
different.
map replace across, something that's held, like hold of 1, 2, and 3, and the replacement is just adding 1 to each of those things.
Oh, sure.
What you're gonna end up with
Yeah.
is held replacement.
Sure. Yes. Yeah. Sure.
What are you saying? Hold 1, 2, 3 here?
Yeah.
Right. If you map, the point is the replace won't run. It'll just sit there.
Yeah. By the way, Nick was emphasizing to me the fact that this is incredibly close to having, we've talked for a long time about the merger of patterns and functions. And of course, this is incredibly close to that.
You say merger or murder?
Merger.
Okay.
Good to clear that up.
Yes. Right. I mean, it's, because it's very unclear it is interesting that replace is just incredibly close to just doing, if I don't know what
And the only difference might be the fall through case, but admittedly, but the down values when they fall through, they also just don't evaluate. So it is the same.
Well,
thing.
I know, but it was unclear. But function never doesn't evaluate. It's an untyped lambda. It just eats whatever. Well, having said that, it largely eats whatever it's
you can
fed.
give it the wrong number of arguments, and
You can give it the wrong number of arguments, in which case it and I guess we don't have. Here's a question: do we have a mechanism? Okay, so really, I didn't know. Is that obvious that it has to do that? Did that surprise anybody that it did that?
A bit, yeah. Well, there's a complicated case of if you have a function, like if you're using slot, like if you don't, so you basically don't specify the number of inputs, and then and then you give it 10 arguments, but you only use #1.
That's why it has to do this. There's a question about function, about but there is no way to specify in a function, and there shouldn't be, right? A curried version of this.
But isn't that just,
we'll
you know,
evaluate from the
operator
inside.
applied or curry applied or whatever it's called of functions? Isn't that the same thing?
Yes, I think so. That will be curry applied. Is that right? That it will just do the right thing here? Curry applied of that function UV. Oh, come on.
You're
What's it
missing some
complain?
brackets. After the function, you need an open bracket.
Oh.
Don't you need to tell curry applied how many arguments?
Oh, it needs an operator form of applied, of curry applied.
You need to close off the U or something like that? No, telling it the number, okay.
You need to tell it that it takes two, yeah.
Curry applied.
Curry
Of that
applied of
function.
function, comma, 2 of U of V.
Yes.
Right. So you can add the 2 after the function.
Oh, that will work as well, because that's
Yeah.
the
Right,
curry.
that's absurdly curried, but yes.
Okay. Okay, but anyway, so the point is, you're saying map at of replace is equivalent to replace at. Correct?
It's not equivalent in the case where there's held
Yeah.
stuff that you're
In
mapping
most cases,
over.
yeah, except for edge cases.
Is replace at interesting?
I use something like this all the time.
I'd say more convenient than interesting.
Okay, well, that's
Yeah, if you don't have it, what do you have to do to make it? I mean, other than the cases where you can do a map out of replace.
And why is it okay? Replace part is something where you don't know the parts. You'd have to get the positions to find the parts. But here you could have replace at and a whole list of possible replacements, and then the candidate parts to put them at. That seems useful. Let's go ahead and try and make this one.
Okay, sounds good.
Oh.
This is another in the category of there's a matrix of functions.
Yeah, I mean, a lot of these probably aren't that interesting, but there are lots of permutations of take that there isn't a corresponding drop, and there are some while variants that might be interesting to look at.
Yeah, I mean, I think this is it's very useful. These matrices are very, very useful, but they're also kind of terrifying because it's like, by adding length while, did we just sign up to make a length largest and stuff like that?
We don't need these. I mean, this is the point. This is it's like natural language. We should learn something from natural language. Natural language, as you can tell by looking at an English grammar book, does not have these matrices.
If you look at a Latin grammar book, it has a lot of matrices, but
well, they do.
I mean, there are usually
inflection.
some holes. There usually are some holes. So yeah, right. But that's the point. Is that when a matrix like this comes along, this is what makes you think, maybe we could have some inflection, like the meta map stuff that we were talking about, last week. That's an inflection.
Right.
But yeah. But at the same time, maybe in a somewhat Latin-like way, it can become very unwieldy if, when you want to do map indexed, it's, some weird, triple inflected form of map.
Yes. Well, which is why in natural language, things get shortened. And, why the verb to be is usually totally weird in most languages. All right, we should wrap up here. I don't
Drop while is getting dropped.
I don't know. I'm not sure. We should look at it another time. I'm just kind of sampling these. What the heck is discard?
I think drop while, I don't know. I'm unsympathetic to these functions where it's of questionable value, and then also it's easy to implement yourself. And it seems like you can just do reverse of take while of reverse, right?
Discard. Why can't you just do not there?
Yeah, it is. It's literally just an inverted select. But
Well, it's just this has come up off and on over the years. We have cases and delete cases, but we don't have the D version of select.
I mean, it is a common idiom, but it's just sort of like, it's so easy to write not at star.
Yeah.
Yes, I think so. I think
we kind of thought it was common enough, but certainly willing to be argued out of that.
I think it was useful before we had composition, but now it doesn't seem all that needed.
right. Although, yeah, we should make sure that the select page has on it not at star examples.
That sounds like a good action item.
Okay, 2 comments on our live stream, then we should wrap here. Edmund says, couldn't all these drop while be done by a drop by and a while by, where the user gives the function? Drop by.
Yeah, that's something you tell people casually you want to see them later.
The drop by function.
Yeah.
The
drop by Danny's place.
No, but I'm trying to understand what would that actually do. So, I mean, the by functions, I would say, things like sort by have been tremendously successful. What would drop by? So drop by would be something.
It would trim the first elements that match that condition.
Maybe.
I'm not sure. It really is too different from drop, I think. I mean, drop is kind of replacement where not.
I agree that drop is a very
also, it's one of these things, again, it's one of these things though, where it's like, it's I think adding a super kind of funky, not super readable form that lets you do this isn't very useful, because you can also just write it yourself using take by or to take while and reverse and et cetera, et cetera.
Right. I agree with that.
Yeah.
By the way, something we should do, and we should wrap in just a moment here, but some of these things like sort by has been very successful. Take largest by has been very successful. Some of these other things we've introduced have been, to my mind, less successful, like some of the fold pair list stuff, which, and I guess the question is for us to reflect a bit on what's been successful and why. I mean, to me, operator applied, I think, has been reasonably successful. Certainly, I've used reverse applied plenty of times. Have people been using operator applied? That's a deafening silence.
I haven't really used any of the applied functions, just because, partly because I haven't used them, so I don't really understand which does what, and they're all sort of subtly different.
Right. Well,
and also the fact that often they're a bit longer than if you just write it as a pure function.
Yes. I mean, look, I am slowly getting more used to using @star. And I still get a little bit confused by the precedence of some of those things. Anyway, all right, well, we should wrap up here. I'm actually doing another live stream in just a moment here on a quite different topic. But thanks to folks here and thanks to folks on the live stream. See you another